Myself, Amolesh Chandra Ghotok, ECE Department, JNIT. Today experiment is measurement of unknown impedance using shift in minima technique using a waveguide test bench. Objective: to measure the unknown impedance of a capacitive iris and inductive iris. This is our microwave test bench setup using Klystron oscillator. This setup is X-band setup. X-band frequency is 8.2 to 12.4 GHz. This is our Klystron power supply. The switch is power on switch. This switch is HT switch. HT is on, then power supply produce electron beam. This knob varying beam voltage and current. This knob varying repeller voltage. This knob varying frequency for amplitude modulation. This knob varying amplitude for amplitude modulation. This knob varying frequency for frequency modulation. This knob varying amplitude for frequency modulation. And this knob is modulation selector, that is CW, AM, FM and EXT. EXT signal feed this point, and this is the output of the power supply. And this knob is meter selector, that is repeller, that is beam current, that is beam voltage. The display showing corresponding value, that is beam voltage, that is beam current, that is repeller voltage. Now this is our Klystron oscillator. This is Klystron mount. This is Klystron tube. This is cooling fan. This is isolator. Isolator allow the signal only forward direction. This is the variable attenuator. This is frequency meter. Measure the resonant frequency. This is slotted section. Slotted section set the minimum mode, maximum mode. This is tunable detector. And this is match termination, and the cable is BNC to BNC cable. This is CRO. This is VSWR meter. The VSWR meter power switch is here, but VSWR meter showing 4 scale. One is XWR, the next is expanded SWR, then dB, and last is expanded dB. This knob selector, meter selector, one is expanded, normal and 5 dB. This knob select range in dB selector. This is input selector, always set 200 ohms. These two knobs are gain adjusting. This is fine. This is coarse, and this is the input of this meter. And this is the inductive window, and this is the capacitive window, or inductive iris or capacitive iris. This is inductive iris, this is capacitive iris. Now I am set the power supply. At first modulation select is AM, then beam is minimum, repeller varying at a maximum value, that showing CRO. This is the maximum value, and slotted section varying the maximum point. This is our maximum value, and variable attenuator rotate at the last end, top end. And this end opening, open this end, terminating impedance, and insert the inductive window at the end of transmission line and last end. This is inductive window, and then the match termination. Now measuring the frequency meter is rotated, then output waveform is clipped, then stop the rotation and see the frequency. Two copper foil are there and red line meet this point. This is your resonant frequency, that is 9.74 gigahertz. Now experiment table is there, that is frequency of operation, characteristic impedance Z0, that is 50 ohm, beam current, beam voltage, repeller voltage, and table terminating load of unknown impedance, observation VSWR, mean VSWR, reflection coefficient, and unknown impedance. Frequency is 9.74 gigahertz and characteristic impedance is 50 ohm. 50 ohms characteristic impedance, 50 ohms. Then repeller voltage is 122 volt. Then beam current showing 0.015 amps. Then showing beam voltage 222 volt. Now I am terminating impedance, use inductive iris. Now BNC connector, open this CRO and insert the VSWR meter. Now VSWR set as SWR1, adjusting these three knobs, set VSWR1. Now it is set VSWR1. Then vary this slotted section and showing the scale of VSWR meter, the maximum peak. This is the one value of VSWR. This is the maximum peak, and the value is 1.3. SWR is 1.3. So observation 1, SWR is observation 1, VSWR 1.3. Then the observation number 2, varying the slotted section. This is the maximum. The value is 1.4. Observation 2, SWR value is 1.4. 1.4. Then varying this slotted section. This is observation 4, 3. This is the maximum. Again 1.4. This is the value 1.4. Observation 3, value is 1.4. Now remove this inductive iris and insert the capacitive iris. Remove this inductive iris and insert the capacitive iris. In the same process, insert the capacitive iris and remove this inductive iris. And SWR set is 1. Then varying this slotted section, this is the maximum. The value is 1.32. The capacitive iris, observation 1, value is 1.32. Then the always varying forward direction. Restart low position, then varying. This is the maximum peak. This is also 1.32. Observation 2, 1.32. Now finally varying this slotted section. Restate initial condition. This is the maximum. The value is now 1.32. Observation 3, value is 1.32. Inductive iris observation 1.31, observation 2 1.4, observation 3 1.4. And capacitive iris observation 1 1.32, observation 2 1.32, observation 3 1.32. Now calculating mean VSWR, reflection coefficient and unknown impedance. Now this is the value. Mean VSWR 1.37 and this mean VSWR 1.32. Reflection coefficient is equal to mean VSWR minus 1 divided by mean VSWR plus 1, that is 0.156 for inductive iris and that is 0.138 for capacitive iris, and unknown impedance, that is ZL is equal to characteristic impedance into 1 plus reflection coefficient divided by 1 minus reflection coefficient. Characteristic impedance is 50 ohms. The inductive iris unknown impedance is 68.48 ohms and capacitive iris 66.01 ohms. These reading are measured the instrument, or these are all is calculated. This value is calculating value, this value is meter reading. Only VSWR reading is measuring. Complete the measuring unknown impedance. This is inductive iris or capacitive iris.